Hello everyone, and welcome to Puzzle Buster, Java Challenges Solved. Boy, have I got a challenge for you. The name of today's challenge is Bubble Sorter, and the object of the challenge is, given a series of numbers of negligible length, design a mechanism that would systematically sort through these numbers in ascending or descending order. If you'd like to take a moment to pause the video and think through how you would design something like this, otherwise, let's think through this together. Now, when I say a non-substantial, a negligible length of numbers, I'm speaking on the order of 10 or 100 elements long, nothing that's of the order of 10,000 or 100,000 elements long. And so something that would be an ideal algorithm to sort through such a small set of numbers would be a bubble sorter. And the way that a bubble sorter works is it systematically passes through each element in the array a number of times equal to the length of elements in the array, and it performs swaps of one element with the next based on whether or not the number is larger or smaller. And so one way that you can easily imagine this is imagine you had an array of 3 elements including the integers 2, 3, and 1. And you wanted to sort these in ascending order with a bubble sorter. You want the final product to look like 1, 2, and 3. What a bubble sorter would do is, knowing that there are 3 elements in this array, it would make 3 passes through the array. And it would compare each element to the one after and make a swap based on whether or not it was larger or smaller. And so a bubble sorter would start with an array of this length. It would start with the 2, it would compare the 2 to the 3, and seeing that it's smaller, it would make no swap. It would then move to the 3 and compare the 3 to the next one, which is the 1, and seeing that the 3 is larger than the 1, it would then swap the 3 and the 1. That would be the first pass. Then it would come back again for the second pass, starting at the first element, and compare the 2 to the 1. It would see that the 2 is in fact larger than the 1, and it would make a swap. It would then compare the 2 to the 3 and see that it's not larger and would take no action at all. Then it would go through for a final pass, and it would check the 1 against the 2 and see that it is in fact smaller. It would take no action. It would then compare the 2 to the 3 and see that it's smaller and take no action. And by the end of the third pass, you would have a sorted series of numbers. So understanding that makes it easy to understand how a bubble sorter can take elements of an array of length 10 or 100 long and sort of bubble the smaller numbers to the front and the larger numbers to the back. And so that being said, how would you design something like this in Java? It's not by any means impossible, but it is a little trickier than it sounds. So let's first start with a class that we're calling bubble sort. And outside of the main method, but under the class, let's define an array integer of 10 numbers that are purposely not sorted. And so we'll have 10 integers that we will make unsorted like this, like so. And in the main method, let's make a call to 2 other methods, one of them called display, that will display out to the console the array, and the next one called sort that will actually perform the logic in making the comparisons of the bubble sort. And then we'll call display one more time afterwards to ensure that it was in fact properly sorted. So we'll call display and we'll pass through our array that we're going to call marray. Next we'll sort the array, but since we need to make a number of passes equal to the number of elements in the array, we'll not only pass through the integer array to the sort method, but we'll also pass the length of the array so that we know how many passes to make. And we'll do that by calling the marray.length. Next we'll display the final product by calling our display function again. And that will be everything we need in the main method. So now let's go ahead and declare and define our display. We know it's going to accept an integer array. We'll call this A. Now first, for formatting purposes, let's go ahead and print out a carriage return. Then let's use a for loop, and we'll say for each element that's an integer in the array that we've called A, print out to the screen that integer plus a comma and a space. Pretty simple so far. Now, let's declare and define our sort function. This one we know will accept an integer array that we'll call A and an integer value that we'll call N. So the logic of the sorting method will need to have a nested loop. So the outer loop is going to be the one that controls how many passes through the array we're going to make, and that's going to be based on the length of the array. So for integer that we're going to call I, that we'll set equal to 0, we'll compare I to the length of the array, and if it's not larger than the length of the array, we'll perform the logic in the loop and increment I by 1. Inside this loop, our nested loop, will then make comparisons to each element in the array. And so for an integer that we'll call j, that we'll set equal to 0, we'll check to be sure that j is less than not the length of the array, but because j is going to be referencing the index value of the array, and we know that arrays indexes begin with 0, it's going to have to be the length of the array minus 1, because the last item in the array is equal to the length of the array minus 1. And if it is, in fact, less than that, we will perform the logic and increment j by 1. Now inside of this loop, we'll perform the actual comparison. And the way that we're going to do this is, we're going to check to see if the index that we're on is larger than the index right after. And if it is, we're going to instantiate a temporary integer value and set it equal to the element that we're on. Then we're going to set the index value of the element that we're on equal to the one after that. And then we're going to set the value of the one after that equal to the one that we're on, effectively making a swap. And so we'll do a conditional if statement. If the index value is greater than the index value right after, then perform the swap. Define our temporary integer value equal to the index that we're on. Reassign the index that we're on equal to the index value right after, which will be j plus 1. And then assign the value of the one right after equal to the one that we were on, which we've already assigned to temp. So fairly simple. And hopefully that logic makes sense. Looks like we've got everything correct here. So let's go ahead and run this program to see if we can print out to the console the original array and then the sorted array. Beautiful, look at that. So we have our original array out of sorts, and then we have our final product, which is the same one, except sorted in ascending order. And so a fairly simple algorithm, a very elegant one, and a personal challenge for you at home. What very small, simple change would need to be made to this code to change it from an ascending sort to a descending sort? If you're very keen, you've probably already noticed this, and I encourage you to try this at home. I hope that this has been informative and entertaining, and I look forward to seeing everyone back in the very next video. Thank you so much, and have a beautiful night.